Hello everyone. Waves for beats and Doppler effect. In this video, I shall be talking about the concept of beats and Doppler effect related to sound. First, we shall see the concept of beats. Beats are observed when two sound waves of equal amplitude phase, which are differing slightly in their frequencies, travel in the same direction in the same medium. For that, we can consider first a sound wave of frequency 250 Hz, then another sound wave of frequency 238 Hz. Then when both these sound waves are sounded together, we get the beat. We can observe this. First is the 250 Hz. This is 238 Hz. These are the beats observed. So the phenomenon of wavering of sound intensity when two waves of nearly same frequencies and amplitudes traveling in the same direction are superimposed on each other is called beats. In this figure, we can see the two waves which are differing slightly in their frequencies. When these two waves superimpose, they create a net waveform as shown in the figure C. In this case, we can see that the intensity of the wave is varying, even though the frequency of the wave remains the same. For understanding beats further, we can consider two waves having slightly different frequencies which have same amplitude and phase. Now let the time-dependent variation of the displacements due to two sound waves at a particular location be S1 is equal to A cos omega 1t and S2 is equal to A cos omega 2t. In this case, omega 1 is greater than omega 2. So by using the principle of superposition, the net waveform is given by S1 plus S2. That's equal to A into cos omega 1t plus cos omega 2t. But by using the trigonometric formula, cos omega 1t plus cos omega 2t is given by 2a cos omega 1 minus omega 2 by 2 into cos omega 1 plus omega 2 by 2. Now let us assume omega a is equal to omega 1 plus omega 2 by 2 and omega b is equal to omega 1 minus omega 2 by 2. So the equation for this wave becomes 2a cos omega b cos omega a. Since omega a is very much greater than omega b, cos omega a t will vary rapidly with time and 2a cos omega bt will change slowly with time. Therefore, we can say 2a cos omega bt is equal to constant. So, the result of superposition of two waves having nearly the same frequencies is a wave with nearly same angular frequency, but its amplitude is not constant. The intensity of resultant sound varies with an angular frequency given by omega beat is equal to 2 times omega b, which is equal to omega 1 minus omega 2. Now using the relation omega is equal to 2 pi nu, the beat frequency nu beat is given by nu beat is equal to nu 1 minus nu 2. The phenomenon of beats are used for tuning musical instruments against standard frequencies. Now we shall see the concept of Doppler effect in the case of sound waves. Doppler effect is the phenomenon of motion-related frequency change. It is the apparent change in frequency observed by an observer when there is a relative motion between the observer and the source of the sound wave. As an example, we can consider a truck that is coming from a distance. As it approaches near our house, we feel that the sound increases. And when it passes our house, the sound will be maximum. And as it goes away from our house, the sound decreases. This effect is known as Doppler effect. And it is caused due to the fact that when the source of sound comes nearer to the observer, the wavelength decreases and hence frequency increases due to the compression of sound waves. This can be seen in the following example. In this case, we can see the truck is sounding a horn. At first, the truck is stationary and O is the observer. Now, if the truck begins to move, that is the source is moving towards the observer, then the sound of the horn is as observed. This is because the waves are compressed in the case of front, and the waves coming from the back of the truck, that is after the truck passes the observer, is having increased wavelength. Now we can see some cases and find the formula for the observed frequency. First case is source moving and observer stationary. For that we can consider an observer O situated at a distance of L from source. The initial position of the source is S1. After a time t0, the source reaches a position S2. In that case, the distance between the observer and the source is given by L plus Vs into T0. Here Vs is the velocity of the source. In this case, the direction from the observer is taken as positive. The observer has got a detector which is used to pick up the waves coming from the source. At first, the time taken by the waves to reach the detector which is held by the observer is given by L by V, where V is the velocity of the wave. Now at time t is equal to t0, which is the period of the wave, the source has moved a distance Vs t0 and is at point S2. In this case, the time taken by the wave to reach the detector is given by T2 is equal to T0 plus L plus Vs T0 by V. Now at time n times the period of the wave, the source emits its n plus 1 crest and this reaches the observer at time Tn plus 1 is equal to Nt0 plus L plus Nvs T0 by V. Hence in a time interval Nt0 plus L plus Nvs T0 by V minus L by V, or the time interval is given by Tn plus 1 minus T1. Now the observer counts n crests and records the period of wave t, which is given by t is equal to nt0 plus L plus Nvs T0 by V minus Lv, the whole divided by n, which when simplified becomes T0 into 1 plus Vs by V, where Vs is the velocity of source and V is the velocity of the wave. Now we express this in terms of frequency. We get nu is equal to, which is the observed frequency, is equal to nu 0 into 1 plus Vs by V, the whole raised to minus 1. If the velocity of the source is very much lower than the velocity of sound, then we can use the binomial expansion to simplify this equation further to give nu is equal to nu 0 into 1 minus Vs by V. For a source approaching the observer, we have to replace Vs by minus Vs. Now the second case is observer moving and source stationary. For this situation also, the observed frequency can be derived in a similar manner. In this case, the time period t observed by the observer is given by Tn plus 1 minus T1 is equal to nt0 minus nv0 t0 by v0 plus v. Here v0 is the velocity with which the observer is moving and v is the velocity of the wave. Thus, observer measures period as t is equal to nt0 minus nv0 t0 by v0 plus v, the whole divided by n. This on simplification becomes t0 into 1 plus v0 by v, the whole raised to minus 1. Now if this expression is expressed in terms of frequency, we get the observed frequency nu is equal to nu0 into 1 plus v0 by v, where v0 is the velocity of observer and v is the velocity of the wave. Now the third case is when both source and observer are moving. In this case, the velocity of the observer is v0 and the velocity of source is vs. At first, the time taken for the wave to reach the observer is given by t1 is equal to L by v plus v0, where v0 is the velocity of the observer and v is the velocity of the wave. Now, after a time t0, when the wave reaches the position S2 and the observer reaches the position O2, then T2 is given by T0 plus L plus Vs minus V0 into T0 by V plus V0. Now at time Nt0, the source emits its n plus 1 crest and this reaches the observer at time Tn plus 1 is equal to Nt0 plus L plus Vs minus V0 into nt0, the whole divided by v plus v0. Now for calculating the period, t is equal to given tn plus 1 minus t1, which is equal to nt0 plus l plus vs minus v0 nt0 by v plus v0 minus l by v plus v0. Now the observer counts n crests, hence period becomes t is equal to t0 into 1 plus vs minus v0 by v plus v0. This on simplification becomes t0 into v plus vs by v plus v0. Now if we express this in terms of the frequency, we get the observed frequency nu is equal to nu0 into v plus v0 by v plus vs, where v is the velocity of the wave, v0 is the velocity of the observer, and vs is the velocity of the source. Based on the direction of motion of the observer and the source, the signs have to be varied. So this is the end of this video. I had discussed the concept of beats and Doppler effect related to sound waves. If you have got any doubt in any of the concepts discussed in this video, please comment in the section below. Thank you.